And our next guest is actually the honored guest of the symposia this week. Before I get into introducing our guest, I'd like to introduce my co host. I've actually got two co hosts for this segment, so Dr. Zeisel, that must mean you're doubly important. The first co host is Dr. Eric Capio, and he's a senior scientist.
You honor me, nutrition science manager
Nutrition
here at
Science
Balcom.
Manager. And I got Tom Druk over here, and Tom is the Senior Manager of Marketing for choline here at Balchem.
Right.
So thank you both for joining me. And then our honored guest, Dr. Stephen Zeisel. Dr. Zeisel, I really enjoyed your presentation last night. Before we get into that, what I'd like to have you do is just talk a little bit about yourself, right? You've got quite an impressive resume, if you will, in terms of the list of schools that you've gone to. So if you wouldn't mind just kind of walking us through that and tell us a little bit about yourself.
Sure. I went to MIT as an undergraduate. I went to Harvard Medical School. I was a resident at Yale New Haven Hospital in pediatrics. I then went on to get a PhD from MIT in nutrition and metabolism. And then I was a professor at Boston University School of Medicine, and then in 1990 came to the University of North Carolina, Chapel Hill, and was asked to create a nutrition department that bridged the School of Medicine and the School of Public Health. Did that for 15 years. Happily, that department grew nicely and was ranked as one of the top 5 in the country. At that point, I saw there wasn't much upside and a lot of downside to where that department could go. And so I moved on and decided to create a new research institute at the university that focused on precision nutrition, or using all of the information that we could pull together to try to identify why people differ from each other in how they need nutrients and how they respond to them. And so I created the Nutrition Research Institute, which is part of the organizers for this meeting today. I now am a happily emeritus professor, and now my major interests are helping people who want to do choline research and doing my bonsai trees.
Very interesting. Now, speaking of choline, you gave a presentation last evening to the audience. It was titled History and Contribution in Choline Science. Can you kind of give us just an overview? I know you went through a lot, but I found it very interesting, starting from the very beginning to where it ended up.
So at the time I entered research, my PhD years and thereafter, people didn't believe that choline was a required nutrient for humans. There had been some studies showing that dogs needed it and that rats needed it to survive, and dogs who didn't get enough developed liver troubles. But all the textbooks said humans didn't need it. And I couldn't understand why the textbooks would say that, because if dogs, rats, and mice and everybody else needs it, why wouldn't humans need it? And so I was able to write grants in my first years as assistant professor, that were funded by the National Institutes of Health to do a critical study. And that study was one in which we put people in a research hospital. We controlled their diet completely for 42 days. And after a period of 10 days giving them a complete diet that contains choline, we gave them the same diet but pulled the choline out of it. And we asked, did they get sick? And lo and behold, most men and most postmenopausal women got sick. And premenopausal women were a little different, and slightly less than half of them got sick. And by sick, I mean they developed liver damage or muscle damage and fatty liver. And our design of our study was such that we had to stop feeding them the choline deficient diet as soon as they presented with one of those problems and give them choline back and show that we could reverse it. and we let them go from the study after we reversed it by just giving them the same diet but putting the choline back in.
And how deficient were they in choline, those diets?
It was about 10% of what we think the adequate amount is. That's the lowest we could get and still feed them some kind of things that look like food. And again, 42 days is a long time to be trapped in a hospital with everybody watching what you're eating. And so that study went well, and the first study was only in men, and we showed that when you did that, men required it. We then repeated the same design in using women, and we found, as I said, that postmenopausal women looked a lot like men, and premenopausal didn't. So it seemed logical there was something different about premenopausal women than postmenopausal women, and obviously that's estrogen. And so we looked back and found that estrogen turns on the ability to make some of your own choline in the liver. And that estrogen rises very sharply during pregnancy, so that by the third trimester, it's reaching a maximum. And that's exactly when this ability to turn on your ability to make new choline is maximal. So women were designed during pregnancy to make some of their own choline. And that was extremely interesting to us. And as I said, at the same time, we were studying infants, and we found that the mother is delivering huge amounts of choline to the infant during pregnancy. And so that's probably why women were designed to be a little less sensitive to diet than men are, because they have to bring a baby to pregnancy, to successful pregnancy. And we then wondered, what is that choline doing? And we started to look at brain development, and other researchers that are presenting, and I talked about, found that you could affect memory in mouse and rat models. And we were able to show that you could actually, with choline in the diet, giving some or not giving some to pregnant mice, could change how the stem cells that will form the brain multiply and form the structures of brain. And that was a permanent effect. If you missed a critical window in time, you never could make it up by feeding the baby mouse properly. And so that was one long area of research for us. And the other point of my talk is that when I started in 1970s and 80s, there was very little interest in choline, and now there are hundreds of publications each year, and this meeting is presenting some of the newest research in the field.
Very interesting. Eric, what kind of questions you might have?
See, I'm so curious. I love the fact that you talked so much about how, this sort of first 100-ish years of choline was a fairly lonely place, in your words, right? And
I
now-
wasn't there for the whole 100 years.
Then now this post IOM report, 25 years.
Yeah.
Maybe walk us through some of the changes that you saw, maybe that you expected, some that you didn't, and then perhaps where you see the next 25 years going.
Sure. I think that most of the research in choline occurred around the biochemistry of choline, what it was used for, what it looked like. And it wasn't until there was a human function for choline that it was important to humans that people became more interested. And so in the paper that first showed that humans required choline, that first study in men in the hospital, appeared in 1991. And so by 1998, the U.S. Institute of Medicine, which is now the National Academy of Medicine, made dietary recommendations, what people think of as the recommended daily allowances. And they went through, and for the first time ever, in 1998, choline was included. And that was a governmental, a semi-governmental, expert report. And once that was present, researchers became much more interested. The textbooks changed about choline. And the number of investigators starting to work in the field started to multiply, and they came up with interesting results. And by 2016, the European equivalent of the FDA and the Institute of Medicine report came out with their own. It's called EFSA, and they came out with a report saying choline is required and recommended how much people should be taking in at various ages. And that helped on the European side to make the recommendations. The Food and Drug Administration in 2007 became interested in choline because we reported that it wasn't really an infant formula at the concentrations that it's in mother's milk. And they said, gee, if it's important for brain development and mother's milk has it, well, infant formula certainly should have it. And they required all commercial manufacturers in 2007 to modify their content to mimic what's in human milk. That was a big thing. And by 2016, 10 years later, 9 years later, the FDA went on to say that when you label foods, the food label can include choline. And they set up recommended daily intakes that could be used on the food labels at that point. So that's a big thing because now the consumer is starting to see choline is in, they can look for what contains a good amount of choline.
I'm curious, how did you establish what those requirements were? Were there dose titration trials done?
No, so the human study that I talked about, which eventually included about 165 adult humans, we never did children because we weren't allowed to, showed that for most people, if we gave them a certain amount of choline, we could reverse the damage we caused by taking it away. And for a 70-kilogram man, that was 550 milligrams. For a woman who weighed less, the committee who made up the references figured, well, 400 milligrams, 425 should be about right because that's just weight reduction calculation. For children, they said, well, we don't have any children's data, but we know that breast milk contains a certain amount, and we know how much breast milk on average a baby takes. And since breast milk is probably designed properly, we will take that amount and set it as what the infant should have rather than just taking body weight and reducing it from adults. And for pregnant women, they said, well, a woman requires about 400 milligrams, and it takes about 50 more a day to make a baby, so we'll add 50 in. And those calculations were rough, but that's how the recommendations came about. The Europeans who did it 16 years later did a few more elegant calculations, but in the end they came out with recommendations within 25 or 30 milligrams of what the American recommendations are. So it came out roughly the same, but there wasn't a huge amount of information to base it on except that adult men required choline. And later on when we studied women, that women required it, but they didn't adjust it based on genetics, which they probably would if they revisited it today.
Yeah, I'm kind of curious, based on the research that's recently come out of Cornell, where it shows that mothers taking choline during gestation, it'll improve the mental acuity, and I don't know if that's the right word, of the offspring. I'm wondering if they may want to consider revising those based on that. Do we know how much is required?
I think, again, at the time, the recommendations, and in nutrition language, it's called DRIs, dietary reference intakes. That panel met in 1998. We didn't know nearly as much, really just a few men studying men. Now we know a ton more, and it's time to revisit the DRIs. We know now that women are different from men in some ways, so that recommendation could get adjusted. Two, we know that about 10% of men need much more, 850, to get better. We know that genetics makes a difference and that the people aren't all the same in their genetics. It depends where they came from, Europe or Africa or Asia, and that they have different genetic variants that might make them more or less susceptible to eating a low choline diet, and that could be used to adjust it. All that could be considered now and would be very much worth revisiting. And how to get that done is a good question. In the United States, the dietary reference intake panels that make these considerations have a process now that they go through. The last one they did was for energy intake in 2021. They haven't done one since. And they need a governmental organization like the U.S. Department of Agriculture or the NIH to sort of sign on to taking on that this is a worthwhile question to take on and participate in some of the funding. And so that's a question of how do you, there are probably many nutrients that could use reconsideration. How do you get that accomplished and make it happen? The first time we were extremely fortunate that the U.S. Department of Agriculture has a division called the Agricultural Research Service, and the director of that had attended a number of talks on choline and became convinced it was important. And so when the panel to consider the B vitamins was being put together in the 90s, she was part of the funding for that panel, and she insisted that choline be included because she felt it was worth consideration. And that was a major inflection point in scientists and clinicians, health professionals being interested in choline, because for the first time they had an expert panel say, this should be something you think about.
So what are you especially excited for in the next 25 years of choline research? You've seen a lot of change over these past however many years. Where do you see this going, and what particularly excites you?
Well, I think that nutrition is a really complicated area. There's metabolism, and we know now that it varies greatly between people based on their genetics, but probably also based on the microbes in their gut, the microbiome, on their behaviors, on food processing, on 1,000 things. And humans are overwhelmed with that type of complexity. But the advent of artificial intelligence, the ability to use massive computer power to think about what all this data means, really promises that we could handle much more complex questions than we have in the past, and we could be much more precise in telling people what's their metabolism like, which nutrients are they most likely to have to be more careful about, what diets might help them do that, what supplements might help them do that. And so I'm very hopeful that this area of precision nutrition will develop markedly. I think that, and again, I'm trying to move that forward by focusing commercially on the genetics. Can we offer women and men a genetic test that tells them whether they need more or less choline? But that's a very crude beginning, and I see that in the next years we'll have developed the data that can train these massive computers to say, what are the patterns? How can we tell that somebody needs more choline and do it very precisely and tell them they should get it during pregnancy or they should get it when they're older. And we'll do a great job at that. And we have to start simple, so the genetics are the most developed, and that's why I'm starting with the genetics. But other people are working on the microbiome. Eventually we'll be able to put the two together, and then maybe we'll get to the harder problems of what is food processing doing to the food or this or that. But we can build it slowly. But maybe the way things are going with artificial intelligence, that'll occur a lot faster than I ever thought it could with simple human brains.
I know one of the one of the things that you've worked on, Dr. Zeisel, since moving on to this new stage, is you're working with a company that actually develops a proprietary test
Yeah.
and identifies more of that. Maybe give you an opportunity a little bit to inform how your research into the genetics and
Sure,
testing?
I'd love to do that. So first of all, for women who are pregnant, there are a number of very common genetic variations that women can have. It's- And some of them increase their choline requirements greatly. And pregnancy is a time when they have to deliver a lot of choline to the growing fetus and infant. And we can identify who those women are and recommend a prenatal vitamin that contains adequate amounts of choline, because unfortunately, almost none of them do. And some that do contain just a touch to be able to put on their label, but not the amount needed. And as pointed out in earlier, there are some studies out of Cornell that suggests that women may need much more than right now the current adequate recommendation is to have the best baby they could have. And so those genetic tests for women, and then the second product that's about to come to market is we can identify men. About 15% of men in the United States who have a genetic variation that makes it hard, it makes their sperm not swim well, that can be overcome by giving the things in metabolism that they have trouble making and then make them theoretically fertile again. And so that the second product is a product in male sperm. And then some of the research for the future is some people are susceptible to fatty liver as they get fat, as they get obese. And fatty liver causes problems in metabolism like insulin insensitivity and type 2 diabetes. So if we could identify who's susceptible, we can show that they can reverse it with choline and a few other nutrients to reverse that. So again, a genetic test that can identify those men is coming down the road.
Interesting.
And that company is SNP Therapeutics, if people want to look it up. SNP.
You know, I've been very impressed with the list of presenters that have been presenting here. The audience that you've assembled represents some of the best researchers in the country. So it's very technical. If you could just kind of, I know this is a scientific audience, but if you could boil it down, if you were in front of a consumer audience, what would be one key takeaway that you would talk to consumers about?
Sure. So we've had outstanding data that's been reproduced in many, many laboratories around the country, from many laboratories, that choline affects the development of the brain in animal models. And now we're starting to see in this conference and in recent research around the world that similar things can be seen in people. And that's an extremely important piece, because mice aren't people, but we get our hints from mice, and then we can ask in people, does it happen? So I'm seeing presentations here that mothers who got a diet supplement of choline during pregnancy, their children 7 years later are doing better on certain types of memory testing. Their attention is better, a big problem for us in this country. I'm seeing studies that babies who were exposed to alcohol while they were in utero because their mothers drank have problems with cognition and thinking and attention, and that the first studies are coming out now that they can make a difference by giving choline early in life and reversing some of that loss in cognitive ability. And in fact, there may be a genetic test that can tell you which babies are going to do better when given that choline than others, so that you can focus and target the treatment to the babies who need it most. And so there are a number of talks in these 2 days that are starting to say we can move the hints that we got from studies in animals to people. And it's those people studies that could convince the prenatal manufacturers that they better cook choline in, that the governmental agencies should revisit the choline recommendations, and the FDA, again, when they think about infant formula or prenatal vitamins, should be making recommendations. And most important, we might penetrate the medical and health professional organizations better because they've been slow to take up the the fact that choline is an important nutrient. You can't continue to, for instance, intravenously feed people in the hospital with solutions that contain so little choline that they get liver damage and liver treatment. You have to do something. And you can't take women during pregnancy and give them no advice that increases their choline so that they reach at least the recommended intake, because in America we're about 30% below the recommended intake, and America is a well-nourished population. And when I looked in the Gambia and Africa, they were at half or less than half the recommended intake. There's a lot of women going around not realizing that they either have to eat differently or take a prenatal that corrects for their eating habits and get choline in it. So I think, and we're learning today that as you get older, memory and other things may be affected later in life. And so, I think there's this kind of research that will help to make health professionals pay attention and governmental organizations to make recommendations that the health professionals need to follow.
Dr. Zeisel, this has been very interesting. Appreciate you spending time with us here this afternoon. And I really, really appreciate and want to thank you for your contributions to choline research.
Thank you
very
so much. My pleasure.
You're very welcome.